Hi students, I'm Praveen Sebastian Paul. In this lecture we are discussing the KMAP for SOP or Carnot map for sum of products. For the SOP, that is the sum of product, each cell in a KMAP is represented as a minterm. If there are n variables for a given Boolean function, then the KMAP will have 2 raised to n cells, and we will fill these cells with 1 whose minterm output is 1. Let us check the KMAP for 2, 3 and 4 variables. Firstly, we are discussing the 2 variable KMAP for SOP. Let us say we have 2 variables x and y, then there will be 2 raised to 2, which is equal to 4 cells in a KMAP. Each cell has a scripted number at the bottom right corner. It is a value of the minterm. So, if a cell has a number 2, then it represents the minterm M2. If the cell has 3, then it means the minterm M3. If cell is 0, then which is meant by the minterm M0. Next, we are discussing the 3 variable KMAP for SOP. Say we have 3 variables x, y and z, then there will be 2 raised to 3, which is equal to 8 cells in the KMAP. So in the representation, x is represented as a row and yz's are represented as columns. The row x has the values 0 or 1, and the columns yz has the values 0, 0, 0, 1, 1, 0 and 1, 1. Each cell has a subscripted number at the bottom right corner. It is a value of the minterm. So, if a cell has the number 7, then it represents the minterm M7. Now, if we look at the given KMAP, we will see that the numbering scheme is 0, 1, 3, 2 in the first row and 4, 5, 7, 6 in the second row. So, the number differ in one place when moving from left to right, that is 0, 0, 0, 1, 1, 1, 1, 0. This is done so that only one variable change at a time from the complement to uncomplement or uncomplement to complement in every row. So this is why we are representing a shifted phase in a KMAP. For example, in the first row, we have x dash y dash z dash, x dash y dash z, x dash y z, and x dash y z dash. So, only one variable changes at a time as we move from left to right. So, let us consider the first row moving from left to right in the cell-wise position. Firstly, x dash y dash z dash changes to x dash y dash z. Here, z dash is changed to z. The value in the second column of the first row, that is x dash y dash z, changes to the x dash y z in the third column of the first row, that is y dash is changed to y. And in the last position, that is x dash y z is changed to x dash y z dash. Here z changed to z dash. So that is why the numbering scheme in the row differ in one place when moving from left to right. So this is the 2 variable and 3 variable representation. Now we are moving to the 4 variable KMAP for SOP representation. So here we have 4 variables w, x, y and z. So the n, that is the number of variable, is 4. Therefore, the total number of cell gives 2 raised to n, that is 2 raised to 4, which is equal to 16 cells are represented in KMAP as shown in this figure. The rows are represented by w and x, and columns are represented by y and z. Each cell has a subscripted number at the bottom right corner. It is a value of the minterm. So, if a cell has the number 12, then it represents the minterm M12. And in this case, The numbering scheme is 0, 1, 3, 2 in the first row, 4, 5, 7, 6 in the second row, 12, 13, 15, 14 in the third row, and 8, 9, 11, 10 in the fourth row. So as we discussed earlier, this rearrangement or shift in number is done in order to ensure that only one variable is changing while we are traveling from left to right or from top to bottom. So next we are discussing how to fill values in a KMAP for SOP. Say we have a Boolean function f is defined on two variables a and b, and the f is equal to 1. That is, the output is 1 only when exactly one of the input is 1. So we have drawn the truth table with a possible input and output values. That is, as we said, if and only if one variable is 1, then the output results in 1. That is, the input 0, 0 results in the output 0, 0, 1 results in output 1, 1, 0 results in 1, and 1, 1 results in 0. So the minterm representations are a dash b dash is equal to m0, a dash b is equal to m1, a b dash is equal to m2, and a b is equal to m3. To express the function using minterm shorthand notation, we have to consider only those minterms with f is equal to 1. Therefore, f is equal to m1 plus m2. This can also be written as f is equal to sum of or sigma of 1, 2. Now we have f is equal to m1 plus m2, that is equal to sum of 1, 2. Now draw an empty KMAP having 4 cells. Since we are using two variables, 2 raised to 2 is equal to 4 cells. As shown in this figure, now fill these cells marked with the subscripts 1 and 2 with the binary digit 1, and fill the rest of the cells with the zeros. So this can be done similarly in the 3 and 4 variable KMAP. So my dear students, this is how we are filling the KMAP. So my dear students, in the upcoming set of lectures, we will discuss this KMAP solutions in detail. So this is just an introduction of KMAP for an SOP. So dear students, hope you had understood this topic. So my dear students, kindly go through this assignment question. The assignment question is, write about the KMAP for SOP. So my dear students, in the upcoming lecture, we will discuss the KMAP for POS, that is Karnaugh map for product of sums. So see you soon. Until then, goodbye. Thank you and all the best.